Hello, everybody. My name is Matthew Fullerton, and I'll be presenting on minerals, which is one of the first units we did. So, what defines a mineral? A mineral is a natural occurring inorganic element. It has defined and regular repeating internal atomic structure and is not produced by living organisms. The most common minerals in our world today include feldspar and quartz, which you can see at the top of the screen here. Quartz is the kind of clear, shiny one that I think most of you would recognize. So the key classes of minerals are silicates. Silicate minerals are the most common minerals on Earth, like quartz and feldspar in the slide before. They make up about 95% of Earth's crust and upper mantle, and this makes it so oxygen and silicon are the two most abundant elements in Earth's crust. So the building block of silicates are silicates tetrahedrons, which you can see in this picture here. And I'm going to do an example here real quick. So in this model, we can see kind of what we saw in the picture, but in different, so we can see the polyhedral representation again. We can see the 4 oxygen atoms and then the 1 silicone. Here is the space filling, this is just bigger, and then here is also the stick figure. So these are kind of a better representation of what I wanted to show. Other silicates. Other silicates include isolated, single chain, or double chain. These usually appear greenish black and are very hard. Framework silicates, usually very hard as well, and come in pink or white and glassy structures. And sheet silicates, these are usually soft, come in sheets. You can almost peel them apart sometimes, and oftentimes appear very dull or pearly. Carbonates. Carbonates are generally softer framework than silicates. They are often glassy and come in large bunches of crystals. They consist of a carbon atom surrounded by 3 oxygen atoms, and they also usually fizz under a weak HCl acid, which you can see in this example here. So here's the video. We can see as it comes in contact with the acid, it starts fizzing up. Here are some of the most common examples of carbonates. We have calcite on the left and dolomite on the right. Sulfides. These are oftentimes very metallic and shiny. Will have sometimes a smell, a very potent smell, and a chemical formula of S-2. But if you're referring to certain specific compounds, it would depend on what sulfide is combined with. This could be sodium sulfide or sometimes iron sulfide. The most common is galena, pyrite, and saphirolite. Galena we can see in the photo here, but a lot of you might know fool's gold, which is also a sulfide and is also very magnetic. Iron and non-iron oxides. These will often come in black, gray, or a rusty look, maybe slightly or sometimes very magnetic. The most common are hematite, magnetite, and ilmenite, and this comes with a chemical formula of Fe2O3, which consists of iron and oxygen, as we can see in the picture below. And some of the most common iron oxides are hematite on the left, and then we have a very common one in jewelry, which is sapphire, which is a non-iron oxide on the right.